Hello, I'm Brent Farris from the Brent Studios, and today I wanted to go over transformations inside of Unity for the purpose of programming. So understanding the transformations is one of the most important things in Unity, as you'll be doing it constantly in code. You'll see vector 3s and quaternions and vector 4s and vector 2s, all these things that are used to transform an object. That when I say transform, I mean to translate, rotate, or scale an object. So the first thing that you notice when you select an object and you looked in the inspector, you'll see that there's a position, rotation, and scale. All three of these have X, Y, and Z. These can be thought of as a vector 3. So we can use vector 3s to manipulate all three of these things, the transforms. So I'll start off with position. Position's pretty straightforward. I have a translate script here pretty set up so that we can code something to happen to this object. So what we're going to do is type in transform dot position, and this is basically grabbing this code, this right here, position. Now I can get the X of that, I can get the Y of that, and I can get the Z of that. And I can also set it to a vector 3, a new vector 3, which then has an X, Y, and Z. So if I put this to 2, 2, and 2, what's going to happen is this object is going to be translated to, when I hit play, to 2, 2, and 2. Oh, when I drag the script to the object, of course. If I hit play, it'll be transposed to 2, 2, and 2, or it should be at least, but it was not. So that is, oh, I did it to the rotate script, I'm sorry. Let's cut that out and go to the translate script, and instead of just, we'll go to the translate script and save that out, sorry for that, to the position 2, 2, 2. So now if we hit play, you'll see that it moves up to 2, 2, and 2. You can also see that we can add, so plus equals, we can add 0.1 f to each of these, and it will constantly move since this is in the update function. We'll talk about functions in Unity and pre-made functions later. But you can see now the object is moving. So that's how you modify the position, and that's how you can alter positions of objects. So I'm going to comment this out because I have two other scripts that I want to show, and I need it to stay in place to make sense. Now rotation we'll do last since it's a little bit special. Let's go to scale. There is if you go inside of the transform and you look for scale, you'll find two kinds of scales, a local scale and a lossy scale. What you'll pretty much be working with is local scale, which you can see is a vector 3 right here. So again, we can use our new vector 3 to transform this, and we can set it to 2, 2, and 2 once again. If I apply this script scale to the object and hit play, you'll see that it got fat. It just blew up a little bit. Now we can do that same thing over time. We can do a plus equals, minus equals, divide equals, times equals, anything you can think of that has to do with vector 3s to this object. So if I add this to the local scale, what's going to happen is it's just going to infinitely grow. So now this object has grown in size, and that's how we can alter the scale. So let's comment that out now that that's finished, and we come to rotation. There are two main kinds of rotation that you'll wind up doing in Unity. One is the transform.Euler angles. What Euler angles are, if you don't know what Euler basically means, just think of it as vector 3. So let me retype this so you can see. Euler angles, you can see vector 3 is over here. So we can directly alter this by saying is equal to new vector 3, 0, or 2, 2, and 2. If we add the rotate script to the object and we hit play, you'll see that it's going to rotate in 2, 2, and 2. Possibly. Actually, it didn't. Oh yeah, it did. It was just so small. Sorry, these are degrees. Euler, sorry, I said vector 3. It is a vector 3, but Euler is degrees, basically. So we'll probably want to do something more dramatic, like 65, 65, and 65. So there you go. rotates to 65, 65, 65. Euler angles is basically human speak because we all know degrees, and computers often run in what's called radians, if you haven't heard of those before. And what it brings us to is the transform dot rotation. You can see that there is a local rotation and a rotation. Local rotation works inside of an object, so if this is a child of something, you can do the local rotation, and rotation is the global rotation inside of the world. You'll see that it's set equal to a quaternion, and a quaternion is basically a kind of matrix. And so what we have here is a float x, y, z, and w, and quaternions are used so that we can rotate objects around and look up and rotate correctly without getting into what's called gimbal lock. If you looked it up, you'll figure out why it's so nasty. It's in things where if you look up and it starts spinning like crazy, that's what gimbal lock is. So in here, these are a little bit harder to understand. If I put it to like, let's say 2, 2, 2, and 2, and turn off this here, you'll see that absolutely nothing happens. Now if I make it a smaller number, 0. Let's say 1.5, and let's just make that 1.1, I guess. Hit play. You'll see that it turns. Now you can see why this is so much harder to understand. It's just a little bit different. You're not using degrees anymore. It doesn't make any sense. All three of these have 0.15, but yet this x is 13.8202, and then these two are 19.44044 or 004. It's kind of confusing. Now what you'll use the quaternion for, you'll probably get it as a result and pass it into your rotation, or you can do a quaternion dot and then you can get other things, like you can do Euler from here. So now I can say 65, 65, 65, assign it to the rotation without going through Euler angles. You'll see that it converts that to Euler angles. It goes 65, 65, 65. So there are some various other things inside of here, such as lerp and look at and slurp and axis and angles and dot products and all that stuff. So quaternions can do all of that stuff directly to the rotation if needed. And the identity is basically like zeroing out. If you know what an identity of a matrix is, it's like a diagonal set of ones that you'll see. It just sets it back to kind of like this default value. So that's a way to, that's a little bit about transforms and how they work. I can also, since I made the other ones update, I can update this one. Let's update it by 5 degrees each update. And there we go. It rotated and acted quite weird. So there you go. That's also, I guess before I get off, I can go over a couple more things. There are transforms.rotate, which is an actual function which takes in a vector 3 in Euler angles, or it takes in an axis and angles, Euler angles, axis angles, XYZ, all that stuff. An axis is just the rotation axis. It's kind of like Y is up, so rotate like that. But if we do this, it'll constantly update. If I put it at like 1, 1, 1. Hit play, you'll see that it rotates. And it just keeps rotating. So there are functions set inside of the transform that help you move things around. There's also a translate function here, which allows you to translate an object. Say if I did a vector, I'm doing this inside of the rotate script, I know, but just the principle of it. Let's translate it by 0.1 f. Let's copy that value. Oh, another bracket. And save that out. Hit play, and you'll see there it goes. It gets translated. So there you go. That's a high overview of the various kinds of things inside of, let me get back to the Euler angles and whatever so you can see that. That's a demonstration of how you can use the transforms and how they work inside of Unity. So whenever you see me scripting and you see all of these transforms and vector 3s and quaternions fly by, you understand a little bit more about what they're doing. So until next time, have a good day.